All right, folks, here's a demo on math and logic in Max. So once we have some numeric values, those might be from volume measuring or motion tracking, we may need to do some math or comparisons on them to execute other things further down the road. Like, for instance, we want to play a video if the volume rises above a certain level. So how do we do that? In our super patch, if we go to the math section here, I've got some basic math examples for you. So addition, subtraction, multiplication uses an asterisk, divide is a slash, modulus, etc. So if we have an object like plus 100, this does what we may expect. We're going to put a number in here like 5 and hit enter, and the result is 105. Similarly, if we go here and put a 5 minus 100, we're going to get negative 95. Multiplication also works as we may expect. If we put a 2 in here, we'll get 14. But I do want to show you the difference between floating point numbers and integers. So if we try to multiply this integer 7 by, say, 2.5, right, we might expect then to get 17.5. But we get 14. Whereas over here, if we say 2.5, we get 17.5. Why is that? So when we multiply a float by an integer in Max, before the multiplication happens, it converts everything into integers. So, and it does that not by rounding, but by just chopping off the integer. So saying 2.5 times 7 as an integer is really like saying 2 times 7. Whereas if we have 7 dot, that's saying really like 7.0. So we're saying 2.5 7.0 will give us floating point math, and we'll 17.5. That is also true of division. So modulus tells us the remainder of a division. So if I do, for instance, 21 modulus 3, right? 21 divided by 3 is 7, so I get 0. Whereas if I do 22 divided by 3, I get 1. So it's saying the remainder, right? If you remember old school long division, the remainder of 22 divided by 3 is 1. There's 1 left over. Okay, what else? The other thing I'll show you here is not minus. So if we're thinking about subtraction, there are many times where we might want to do an operation like 1 minus something, or 100 minus 5, for instance, right? But if this is our object, we're doing minus 100. So we want, like, how do we flip it, right? And so we can flip the equation with a not minus. So like, if we do 0.2 not minus 1, we should get 0.8. If we did 0.2 minus 1, we would get negative 0.8, whereas this gives positive. And just to look at that again side by side, let me unlock this, copy these things over, get rid of that, and make this a normal minus. And so now if we do minus 0.2 minus 1, negative 0.8. Right, so it's just flipping the equation. So you'll notice these math objects have a second inlet, right, which we could change then the default value here. So I've got something minus 10. So if I say 30 minus 10, I get 20. I could change that. If I change that to 5 and hit enter, it doesn't appear that anything happened, and this can be tricky because there's no visual cue here. Because this outlet is not hot. See how it's blue and the red one's hot. So the red outlet, anything going, or I'm sorry, the inlet, the red inlet, anything going into the red inlet is going to trigger this to happen. Whereas anything going into a blue inlet, the object is going to store that value, but it's not going to trigger output. So now, even though we can't see it, this is in fact a -5 object. So if I come back here and do 30 again, I get 25. Okay, that is one of the less intuitive things about max. So be very mindful of this. You can change this value. I can change this to 7. And it looks like nothing happened, but I go here and run my calculation again. Let's do 20. It becomes 13 because the 7 is stored in here. If I do another calculation, 40 is 33. So the 7 will remain in this object until I change it again. Okay, so I wanna show you a way that we can deal with that. For instance, we may want this to trigger output when this changes too, right? If I go back to 10, I want it to trigger an output. So how do we do that? That has to do with the trigger object. And triggers let us order or sequence output in a specific way. Normally in Max, the flow of data, if we've got something with multiple outputs, it's going to go from left to right, which can be slightly unintuitive for those of us coming from cultures with languages that read right to left. Max functions the opposite way. So if we look at this trigger object, this happens first and that happens second, right? So in terms of the computer, it happens very quickly. It will appear instantaneous to us, but in actuality, this happens first and then this happens. So as an example of that, I'm going to look at the Max console here. And so what trigger does, we can call trigger with the word trigger or just T, and then we give it how many outputs we want. So here I'm telling it I, which means I want 2 integer outputs. If I did FF, it would be 2 float outputs. IF would be 1 integer, 1 float, etc. And then I've got a box here. So if I, for instance, put 10 in here, let's trace what's going to happen. 10 goes into the trigger. The trigger first sends the 10 out its right outlet, which goes into the right inlet of this message box. The message box then gets rewritten. So if we use the right inlet of a message box, we change whatever it says. As an example, and just a number box connect to that. Whatever I put in here that goes into that inlet is going to change the message box. But that doesn't trigger output on the message. Again, if I connect this up to a print, so the message changes to 5, but it doesn't print. Whereas if I click the message, it will print. Or if I bang the message on its left inlet, the hot one, it will print. So going back here, the 10 goes into the trigger, comes out here, sets the message to 10. 10 then also comes out here. Message interprets that as a bang and outputs the 10, right? So let's try it with a 7. Boom, there's our 7. And you'll notice we get this A7. So we're saying we've added an argument to the print. A gives it a name, so we know that that's coming from this print. Because we've got another print over here. B, we've got a bunch of prints down here. How do we keep all these straight? Well, we can label them. And those can be whatever we want. We call them cat, dog, alpha, beta, whatever. Let's look at this one. This one does the opposite, right? So this one is sending the first output to the hot input of the message, and it's sending its second output to this rightmost inlet on the message. So if we think about this conceptually, this is going to seem weird, but I'm going to put a 5 in here. When I hit enter, the 5 is going to go in. It's going to come out here first. So it's going to trigger this. The message will interpret that as a bang. It's going to trigger this, and it's going to print a 1. then it's going to output the 5 here, and it's going to reset the message to be a 5. So this will appear as a 5, but it's going to print a 1. Watch, enter, that becomes 5, but it printed a 1. So we can do all kinds of weird stuff with this. We can use integers, floats, symbols, those are like words, a list of other things, a B for a bang. So looking at this trigger, I'm going to output a bang here, an integer here, a cat here, the word cat, and a symbol, which is like a variable for a string, any kind of text, here. And I'm going to give it dog. So I'm expecting, I'm going to put this in dog. The symbol then, dog is a symbol. The word dog is a symbol. So I'm expecting print4 to be a dog. Cat, it's going to give me cat no matter what. So 3 is going to be a cat. Integer, dog is not an integer. I'm not sure what we're going to get there. Maybe we'll get a 0. And then B for bang, dog can trigger a bang. It is a thing, so it's going to trigger bang. So print1 should be a bang. So we hit dog, and we get dog, cat, 0, and bang. And notice the print order, right? I said max goes right to left. So even though this is our 4th outlet, our 4th print, it happens first, then the 3rd one, then the 2, then the 1, because it goes this way. Okay, so that's some pretty abstract stuff with max in terms of how you trigger or control these outputs, and we'll look at why that's important momentarily when we look at comparison logic. Okay, so where are we getting to with all of this? We want to be able to compare two numbers, right? We've got some volume. We want to be like, is the volume from the mic greater than this value? And if it is, trigger some change, trigger some video, trigger some effect. So we can do some basic conditional comparisons within max with greater than, equals, less than, equals, equals objects. So this is like saying, if I put in a value here, is this value that I'm going to input greater than 5? If it is, output a 1. If it's not, output is 0. So that's like saying true or false. This is a true-false conditional. So for instance, I put a 7 in here, hit enter. Yes, 7 is greater than 5. It gives me a 1. I put a 3 in here and hit enter. No, 3 is not greater than 5, so it gives me a 0. Like the math objects, I can change this dynamically too. So I could put a 7 on this side. Nothing happens, and I can test that, right? Because I have a 3 here. 3 is 3 greater than 7? No, I would expect that to be a 0. But what if I put a 1 in here? I would expect 3 to be 1, but I still don't get any output, again, because this is a cold inlet. If I go back here and put in 4, 34, sure, enter, 34 is greater than 1. What if I put in 2, right? 2 would be less than 5, but it's greater than 1. It remains on. So with these greater than and less thans with the math objects, what if we want to dynamically change this value, or we want to run the either math or run the comparison when we change that right inlet? We can do that with a trigger. So let me set this one up. So this one, you notice I've got the same thing on the left hand side. I've just got a number box, but over here I've got a number box going into a trigger with a bang and an integer. So what's this going to do? I put a number in here. It's going to put an integer in here, which is going to set this. Then it's going to bang the hot inlet. So whatever it's received here, it's just going to be like, give me that again. Give it to me again. And it will run the equation. So let's set this up. We'll do 5 again. All right, so 7. Is 7 greater than 5? Sure. Now, what if we want to change this to something we know is not right? So we're going to change it to 10. So 10 is going to go in. 10 resets this. Now, normally we saw up here, right? Nothing would happen. But then it's going to give us a bang and hit here, and it's going to run the 7 again. Is 7 greater than 10? No, so we should get a false response. And there it is. So now we can change these numbers as much as we want on either side. And I'm just clicking and dragging to change that number quickly to run our comparison over and over, regardless of which side of the equation we're changing. Now, a problem that we'll run into with these objects is that they give us an output, the 1 or the 0, every time something comes in. So for instance, if, turn this off real fast, looking at this metro, we're going to have a metro go into a number box every 300 milliseconds. It's going to output that into our comparison. So if our number is 5, and I hit enter, 5 is not greater than 10. We got a 0, it didn't change, but we saw that bang here, right? So now if I turn on this metro, every 300 milliseconds, it's saying, is 5 greater than 10? No, 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 no. It doesn't look like that with our toggle, but with the bang button, we can see that actually it's spitting out zeros over and over and over again. If I add a print in here and look at this, we'll see print 0, print 0, print 0. It's just constantly churning that out. Now, you might ask, like, when is this a problem? It's going to be a problem very soon. Because what if this is in fact a ADC with a meter that we're trying to measure some volume for. And we want to know if it's greater than 0.02. Remember the sampling rate of this meter, 50 milliseconds. It's spitting out data very fast, constantly, so this calculation is going to run all the time. If we wanted to do something based on that, then let's say we wanted to play an audio file, a short audio file. This trigger, we know, like 1 will start the playlist, 0 will stop it, and it's gonna play like constantly. Okay. And now since it's an audio file, it's generating audio, it's going to trigger the mic input, right? And then it's going to say that it is playing, and it's going to play it again. And so it's going to constantly try to replay that track over and over and over again. That's not what we want, right? We want it, if we detect the change, we want to play once, not a million times. So we can use a change object to see, has this value changed since the last time we checked? So I'm going to run from my toggle into change, and you'll see now this bang happens much less frequently. Only when my voice first passes our threshold does it trigger. And if we run our print down here, we'll see that it is really much more in line with my speaking than than without the change. And so now we can play our short sample without it looping constantly. Okay? There are two other outlets on change that might be useful to us, and they're going to be bangs. One from the transition from 0 to non-zero, and this one from non-zero to 0. So when I start speaking, when this turns to 1, we'll get a bang here. And when I stop speaking, we'll get a bang here. So I see this one, then that one. So those may be useful for triggering some things as well. Needless to say, this is how you could make a clapping device too, if you wanted to. So the toggle can turn things on and off. But that's like pretty rudimentary, right? So what we've looked at today are how to do some math, how to use trigger to control when and how our inputs go to which inlets, and then how we can use change to run a comparison but not run it repeatedly, how to examine data only when that value changes. All of these should be helpful to you for your project.